Hi, everybody, and welcome to Chem Part 2A. I know most of you are students that were in our last session. So a little bit of what we're going to do today will be repeat from, and if you're new, welcome. So the reason that you will see repeat is for the fact that this sessions and stuff was built as a standalone session. Each one of these is standalone, meaning that you necessarily don't have to take part one and A and B to take part 2A and B. That's the reason you will see some repeat. Oh, though I will tell you there is stuff that is not repeated in here, talking about, electron configurations and naming convention and stuff that is important for chemistry. So it does build upon itself, but also like each individual session has to have some little bit of repeat or be completely different to not have it. And being that the introductory pieces of chemistry are naming and balancing equations and blah, blah, blah for stoichiometry, there will have to be some overlap there. So with the events of last night, I'm so sure some of you have heard. My thoughts are with anyone if they were affected by last night's tragedy here at Michigan State. So, I mean, I'm not going to talk about any of that too much. I just want to let you know that my thoughts and condolences are with anyone who was affected by last night. So I think with that being said, Matt, let's go ahead and get started with things, and then we can get this webinar kicked off.
Okay, so I have opened up the first poll. You should see a pop-up screen on your window. And this is just a poll of how many are watching this webinar on the device that you are logged in with. And these metric numbers are important to us. We are curious how many people are taking advantage of this virtual course. So leave this open here. We're already up over 94%. So just a few of you left to answer this, and I'll let it run for about another 20 seconds. Remember, if you do seek continuing education credits, then you do need to answer the poll questions. And if you do not need continuing ed credits, then you can ignore the poll questions. All right, another 5 seconds. We'll close it out. We're at 98% here. And 1 minute. So the majority, Scott, are watching this on their own device.
All right. Okay, so let's go ahead and get started. Let me make sure this is working. All right. Okay, so we're going to be talking about balancing reactions up front, the know-how with them, and just general practice. We're going to do that for a little bit. Then we'll do some review of some math terminology that is required for us to understand. And then majority of tomorrow will be spent on unit conversions, or not unit conversions. Let me be more specific. They will be mostly spent on what we call stoichiometry, which is unit conversions for that of chemistry. Stoichiometry is a big fancy term, and I will tell you, it is just like unit conversions, but where your conversion factors come from, there is a little bit of stuff we need to discuss up front to understand how it works, okay? And I promise everything we do from the beginning of today till the end of tomorrow is 100% linked together by one commonality, and that is the balancing of reactions. All right, so without further ado, let's go ahead and get started with that. You know, one thing I guess I got it this time, unlike last time. There are something we want to talk about, and that's calculators. Most of you are going to be taking a certification exam. Well, okay, I think that was 50-50 last time. So not most of you, but about half of the students we have today are going to be taking the certification exams in May. The deadline for applying is March 3rd, okay? Do remember. And by deadline, that does not mean it has to be to me by March 3rd or to us, but it does mean that it has to have a postmark date stamp of March 3rd. If it's any later than that, it's one of those, sorry to be you, all right? There's nothing I can do about it. Rules are rules. I can't change them for one person, or I'd have to do it for all of them, okay? So
And Scott, just to confirm, that's the drinking water certification.
that is
exam deadline.
drinking water certification exams. That is true, because there are some of you on here who are wastewater operators. So this is a Texas Instruments. The one that I typically recommend is a TI. So it kind of looks like this, and it's a 30XIIS 2S. I typically recommend this one, but this one is acceptable for Texas Instruments. Just so you know, anything up to Texas Instruments TI, and the number here is 36. 36 and lower are considered non-programmable, and you are allowed to use them on the test. Okay, this one is similar to this one, as you can see what you type in here, and you can see your answer over there. But I prefer this one because it's a 2-line calculator, because this one is like a multi-line where it just keeps going. You know, you can see there's lots of them here. I prefer this one. I don't have that one with me, but I do have a calculator today, because cell phones are not tolerated on any exam. Doesn't matter if that's water or wastewater. Programmable calculators are not allowed on water or wastewater either. Okay. I just want to make that clear that this is the type of calculator. This is the one I generally use and recommend, the TIX32S. And you can buy them for between $10 and $15 on Amazon or Walmart or Target or Meijer or wherever you're going to buy it from. All right. Walgreens sells them too. They're a little bit more expensive, but they do sell them. All right. So highly recommend it. You're going to need, you're going to be using a calculator in here. Maybe not necessarily today, but I can guarantee tomorrow we will be using a calculator a lot. All right. So with that being said, let's go ahead and go back to the PowerPoint. All right. So the learning objectives for this is we're going to be working on balancing reactions, understanding some tips and tricks about them, and then figuring out how to do them. We're going to practice them. All right. Before we move on too much. Okay. So again, with us, we're going to be talking about chemical reactions. So the chemical reactions is written only as two things, right? A chemical reaction on one side, or one side of the reaction, you're going to be starting with what we call the reactants, which is your starting ingredients, what you're starting with, right? We're not starting with the products. We're starting with reactants. It's kind of like your recipe of what you want to make thing. So you add everything together, that's your reactants. And as they react, they form your products, okay? So on the chemical equations we're going to see today, one side will be products, one side will be reactants. And we are going to assume that the chemical reaction occurs and it's not at equilibrium or anything along those lines. It's just what you put in and then what you get out. That's the way we're going to be looking at it. Just so we're aware, that is theoretical chemistry. There is no such thing as a pure reaction that what you put in is 100% what comes out of it, okay? I just want to make that clear, because that is true. There is no such thing as 100% reaction. There will always be reactants left over in the real world. But in our world, and for understanding of learning and how this thing works, we're just going to assume that when you put everything in, everything reacts out for the sake of making our lives easier, okay? This isn't a basic chemistry, not advanced chemistry, okay? So we're going to consider a very simple and elementary chemical reaction to learn how to do this initially. So as you can see here, we have H2, which is hydrogen gas. When hydrogen is pure in nature, it is a gas, and it is two of them. Oxygen, when pure in nature, is a gas. You can't see it. It's what we breathe, right? It is an O2. And the reaction of these two together is how you form water, which is H2O. And what's funny about this reaction is you use water to put out fire, but in order to create the water, it's born of fire, okay? And what I mean by that is hydrogen and oxygen gas, you know how you get them to react with each other? It takes a spark, sound like this, right? We give it a little click and then boom, it literally blows up. hydrogen and oxygen blow up together and make water. So they blow up, they light on fire, and water is produced. It's kind of ironic. All right. So here we have H2 plus O2. The left side of the arrow for everything we're going to be doing, the arrow is only going to go to the right, which is where the products are at. So the reactants are going to be on the left side of the arrow. And we're going to think of the arrow, you know, it directs, it's saying that everything goes to the right for products, right? It can be thought of as an equal sign. It's pretty much the same thing as an equal sign. It's the chemistry equivalent of an equal sign. Does that make sense? Okay. But if you look at this reaction, you start to see, well, this is the reactant and this is the product, sure, but something doesn't look right. So the very first thing is when we were talking about naming of compounds in the last session, we learned what these subscripts mean. So if you weren't in the last session, when you see these subscripts on like the H, it means there's two of them. And by subscript, that means the number that's below it. It's not up here like you see for square feet or something along those lines. It is down below. It's a subscript. The subscripts indicate how many of those elements there are, okay? And in some cases, in some of the reactions we'll see parentheses around what we call polyatomic ions. And it means how many of those polyatomic ions there are, okay? So subscripts are indication of how many there are. When there is no subscript, like here on oxygen and water, that means there's only one of them, okay? So when looking at a chemical reaction, the first thing we want to do then is determine how many elements or atoms of each kind we have on each side of the arrow. Because if you look at them, you sometimes, rarely, but sometimes it does occur that you just look at a chemical reaction and it is balanced. It happens, right? Doesn't mean it always happens, but it can happen. And I think I showed an example of one last week where it's just like potassium and sodium reacting together, and it will be balanced automatically, as long as these things are bonded to have the same charge. So here on the reactant side of it, you can see that we have 2 hydrogen atoms and we have 2 oxygen atoms, okay? And then over here on the product side, we have 2 hydrogen, which if you have 2 and 2, that's balanced. But then we only have 1 oxygen, okay? This brings into play what I like to call the even odd rule. And what that basically means is if you have an even number on one side and an odd number, you want to figure out what is the lowest one they have in common, okay? So typically to get the lowest one they have in common is just to multiply the 2 together. So if I have 1 here and 2 there, you would multiply 1 times 2, which would give you 2. So in order to get this to 2, we're going to add a coefficient to it, all right? And what coefficient means is you add a number to the front of the, in this case, molecule. This is a molecule, not, these are atoms. Molecules are things bonded together. So since I went 2 times 1, it gives me 2 is the lowest common number for these to have 2. So if I put a 2 here, that means 2 times every sub number you have here, or subscript. So 2 times 2 for hydrogen means I now have 4 hydrogen atoms on the product side. And then 2 times the 1 oxygen means I have 2 oxygen. So what does that do though? So now we have 4 atoms of hydrogen over here and 2 of oxygen, where over here we only have 2 atoms of hydrogen. So it now made the chemical reaction unbalanced. So the thing about it is, now you look at these 2 and see how I get 4 hydrogen on this side, and you're going to have to add another coefficient in order to balance it. So with that, I have 2 hydrogen. What number do I add here to get to 4? That's the overall question. So we got to think, what do we do? 2 atoms, 4 atoms, unbalanced. Well, 2 times 2 would give me 4 hydrogen, wouldn't it? So if I add another 2 there to hydrogen, you can see that I have it balanced now. Because there's 4 atoms of hydrogen on the reactants, 2 atoms of oxygen. And look at the product. You have 4 atoms, and you have 2 atoms of oxygen to this, okay? So that's kind of how the even odd rule is. As you look, when you have an even number on one side and an odd number on the other, you look to see what the lowest common number is. Sometimes you have to go up one more step, if that makes sense. When we do some practice, let's talk about what I mean by that. Oh, okay. Huh. So, wait, is that forest? No, Matt cleared it out too quick. 2 here, 2 there, 4, all right? If there is no number in front of the oxygen like there is here, that means it's just 1. Means you don't have to write the number 1, if that's what it means, okay? So there are a few other tricks to consider when doing these, and we can talk about them when we get there. So I broke it. So the very first thing you should do this is write the chemical equation out completely, being sure that you know what is the reactants and what the products are, all right? The arrow can help you direct which way the reaction goes. And the other thing about it is you also want to make sure that they are done and written correctly. That's why the naming and understanding the naming convention is so important when writing a chemical equation. Because if you do not balance it correctly, when you miss charges, when you're trying to balance the chemical compound, you might write the wrong thing and you could never get it balanced. It would just be like, wow, I can't do it. It's impossible, right? The other thing is to determine the number of atoms or polyatomic ions you have on each side, okay? Because I will say that sometimes if you have polyatomic ions and they still exist on both sides as the same thing, you should balance them as a singular unit, all right? Treat them as one thing, not 2 separate atoms, because it will become very hard to do. But if it doesn't exist the same thing on both sides, obviously you can't do that. So it's one of those, if you look at it and you see it, you treat it that way, right? So you want to track the atoms on each side by making sure the coefficients that you add, you know how many there are. All right. I think with all that being said, it's now time to go to the practice sheet and work through these together. I'm gonna do some, explain a couple of the things and tricks to it, and then just kind of we'll take turns going back and forth and giving you some time to do them and work it out. The balancing of reactions is so important, especially for this section, okay? And the reason for that is when we do stoichiometry, we start to do it, all of the math for stoichiometry or your conversion factors, mostly 99% of them come from your balanced reaction, okay? So the balanced reaction is very, very important that you know how to do it, okay? So with that being said, let's go ahead and refer. So in this thing, in your packet here, we got to find it. Okay. You know, I need to start labeling these. Okay, so the PowerPoint, I have the whole thing printed off like I imagine most of you do. We want to go towards the back here, behind all the PowerPoints. You are going to see get there. All right. So here's all the PowerPoints. As you can see, I took them all away, right? So put those over there. And then you're going to see the balancing reactions. There's a couple pages of them here, okay? So this is the sheet that we're going to work doing a few over like the next 20 minutes working on some of these, okay? So let me talk about the first trick that I was talking about. All right. So the first thing we're going to talk about is when you see a polyatomic ion, okay? And here, polyatomic ions are these big grouped things like here. And what they are is they represent a ion. So this PO4 is known as phosphate. Here, this is known as nitrate. So now what you do is this is the reactants on the left and over here is the product. So what we need to do is we need to look here at phosphate and see if it stays together. Okay, it does. So when I'm balancing these, we're going to treat them as a singular unit, if that makes sense, okay? And then here you're going to see nitrate and nitrate. The NO3 is another polyatomic ion, and as you can see, it's here and it's over here. Okay, so the very first thing I need to do is I need to choose what I'm going to start with balancing. And I kind of just, you get a feel for this, so to speak, by dealing with this. So we kind of need to look what we got going on and see how to balance things. So here I got 3, here I got 1. Okay, well, those are both odd numbers, so that doesn't really help me out. Even odd trick is where I usually start with these things. So I have PO4 here as 1, and I have PO4 over here as 2, correct? So what I'm going to start with is I'm going to start with balancing this PO4. I have 1 here, 2 there. The lowest common positive or even number they have, 1 times 2 would be 2. So I'm going to go ahead and write a 2 over there. FYI, I would highly recommend pencil, not pen. But I got a pen, so hopefully I don't make any mistakes. And so I have now PO4, 2 is balanced, 2 over here because the 2 up here, 2 times 1 is 2. Now how many potassiums do I have, which is the K? 2 times 3 is 6. I now have an even number over here, and I have 1 as an odd number over here. How do I get 1 potassium to 6? Well, I'm going to put a 6 there. Okay, so 6 nitrates now, the NO3, so I'm going to treat them as separate. I have 6 of them, and I only have 2 here, so how do I get that to 6? Oops, put a 3 there. So I have 6 nitrates, 6 potassium, 6 potassium here. And then my phosphates, PO4, I have 2, and I have 2. Now the last thing I got balanced is calcium. You have 3 calciums here, and I have 3 there. So just like that, this chemical equation is now balanced. Okay. So this next one is a really good one to look at for the even odd rule, okay? Typically how I start with my even odds and balancing is looking at 1 when you have a 2 on the reactant side or product side, vice versa. And if we see here, we have Cl2 and we have Cl3 here. So how am I going to get those to the lowest even number? Remember, you typically you multiply these two. So 2 times 3, the lowest even is most likely 6. So I have to get this to 6, and you do that by 2. And then how do I get this to 6? 3. How many aluminums do I have over here now? I have 2 here and 1 over here. So how do I get that to 2? See? Not so bad, huh? All right, so let's do, yeah, these are good ones right here. All right. These ones right here that you can see bracketed. How about you all take like, let's say 10 minutes to try these, and then we'll go over these, okay? So I'll give everyone 10 minutes to do these. We'll see how everyone does. This one was a little bit complicated, possibly. There is a trick to it I showed everyone last week. But let's see how you all do. So I'll give everyone 10 minutes, and then we'll come back together and try these. All right, so here we go. It's been 9 minutes, close enough. All right. So on the very first thing here, I have sulfur trioxide plus water equals hydrogen sulf. This is sulfuric acid, just so you know. All right, so I now have to balance this thing. So this one's a little bit uncomplicated. I hope we all figure this one out. Remember I said that there are some reactions that just occur and you don't have to balance them, right? So let's look. Being that this is sulfite and that's sulfate, these are, I mean, you could treat them as polyatomic ions, but they're not the same. So it's hard to balance those on each side. And then the other thing is here, you have two oxygen groups here, and then you only have one oxygen group over there. But, so this is where one, you have to count the atoms on, so to speak. So look here, we have one sulfur, I have 3 oxygen plus a 4th here. So I have 4 and 4 hydrogens, I have 2. So what do I have to do to balance that? Not a thing. All right. And no, you don't have to put ones there. As you can see, I've been leaving them blank. I am putting ones where there are. Okay. Okay, let's do the next one. Fe, iron plus HCl. Anyone know what HCl is? I think I have a few chemists on here, or have people. Some people know it as muriatic acid, or others know it as hydrochloric acid. All right. This is one of the strongest acids you can get. All right. FeCl3, so iron 3 chloride plus H2, which is a gas. Typically, when you have a metal that reacts with an acid, you almost always get what's called a salt plus a gas. Usually always get hydrogen gas. So it's got to be careful with this, because if you did react this stuff together, this part of it is explosive. So the off-gassing, if exposed to some sort of spark or ignition, could light up. All right, zinc, a very classic reaction that a lot of chemists do is like a zinc chloride into acid, because zinc is, you can dissolve zinc with almost any acid. Zinc is very reactive metal. It's not all that great. Zinc-based stuff gets eaten away pretty readily. So here we got one iron. We have one iron. So that doesn't really work. So then I have 2 here. I have 2 there. Or 1 here, 1 hydrogen, 2 hydrogen there. So typically I would say 2 times 1, so I put a 2 here and balance it, right? But if you look at Cl and Cl, that ain't gonna work out so good, is it? Because there's 3 here and 1 there. So yes, they're both odd, but this has to be an even number along with this H. So this is one of those I say you got to typically go up, because if I put 3 here, that wouldn't balance. So I have to get the lowest even number, which 2 wouldn't work. If I put a 4 here and put a 2 here to balance, which is the next even number up, 4, so I could put a 4 here and a 2 there, give me 4. But then I have 4 Cl, so that wouldn't work. So the next even number up, it goes 2, 4, and then 6. Well, 6 will work, all right? And the reason for that is if I put a 6 here, I am going to need how many chlorides here? I'll have to put a 2 to get it to 6. 2 times 3 is 6. And then I have 2. So how do I get that to 6? Multiply by 3. Now, the only thing that's not balanced here is the Fe. I have 2 here. How many do I need over here? I need 2. So I had to keep going up in even numbers with this H and 2 to balance before it would work here with the Cl or the chlorine, all right? All right, I was just going back and forth here on what I can do to balance. Okay, so NH3 is ammonia plus NO N2 plus H2O. So I have nitrogen gas over here. I have an even number here, even number there, but my H3 and H2 here are the problem. So I can get, if I put a 2 here, that'll give me 6 hydrogen, and I have 2 hydrogen over here. So I'd put a 3. So it'd be 2, but the problem I have with that would be my nitrogen over here can only be an even number. Because 2 plus 1 is 3, but if I put a 3 here, that'd give me only 3 oxygen, and 2 plus 3 wouldn't equal out. That'd only give me 5 over here. And my nitrogen has to be an even number. So the next step up with 2 times 3 here is 6. That's the lowest common that those even odds have in common with the hydrogens. The next step up would be that 2 and 3 have in common would be 12. Okay. So to get 12, I'd have to put 4 here. That give me 4 N's. And then to get 12 here, I'd have 6. That will work. Okay. So I'm going to do that. I'm going to go 4 here and 6 here because I have 4 times 3 hydrogen is 12. And I have here as 6 times 2 is 12. Now look here, how many oxygen do I have? I have 6 because that's times 1, right? So how do I get 6 oxygens over here? Just put a 6. Now count my nitrogens because everything else so far is the hydrogen and oxygens have been balanced. 12 hydrogen, 6 oxygen, 6 oxygen. Now I have 4 nitrogen here, 4 N's plus 6 N's, which is 10. So how many do I get here to get 10? Put a 5 there. So that's one of those, I was doing my even odd number with the hydrogen to begin with because there's an H2 here. That's typically the ones I try to pick out as the ones that have the 2's like that. Because the 2 and the 3, 2 times 3 is 6. So if we both get those to 6, will the other thing that's attached to it balance? And no, the answer is no, it won't. So that's the next step up from 6 hydrogen would be 12. Okay. Oh, N2 plus H4 plus H2. This already looks like a crapshoot. This one looks hard already. All right. So here, the H's on both sides are always going to be positive or even numbers. The one that is the odd and even is right here, the oxygen and the oxygen here. Okay. So as it sits, I have 6 hydrogens over here, correct? If I were to get that to 6, I'd simply, to get my hydrogens, 4 plus 2 to 6 over here, I would times this by 3. But what's that going to do to the oxygen? That still leaves it in odd number. Remember, if you have even on one side and odd on the other, they have to be even. That's the even odd rule. All right, let me get a drink of water. So what we're going to do to this is go the next step up. So the next step up with, if I had a 3 here, would make this 6. The next step is 12. Okay. So what I need to do to get 12 is I'd put 6 here and I would put 3 right here, right? Which would make this hydrogen 6, 12, so 6 plus 4. And that won't work either because the hydrogen here, yeah, this is a complicated one. All right. The nitrogens aren't my problem. It's these hydrogens. So the 6 over here, 6, 12, put a 6 there. Wait. To get oxygens here, I lied. It would be 3, which would give me 6 plus the 4 there, yeah, that won't work. That'll give me 10, or if I go the next step up, it'll give me 14. Ah, yeah. So the next step up, 6, 12. Remember, the oxygen always needs to be an even. So the next step up from 6, 12 would be 18, but I'd put a 9 here, and that would make that even. So 24. Man, what would that do? 12 here. Yeah, this one sucks. I'm sorry. This one's hard. Yeah, this one's really hard. So this would be 12 at that point. 24. I have to put a 12 there. Okay, well, I'll just tell you, we don't give you any hard disc like this on the exam. And there's an answer key. So I'm going to totally cheat because this one sucks. 1, 2, 1, 4. 1, 2, 1, 4. 8, 2, 4, 4. Yeah, okay, whatever. We're cheating on that one. That one's done. Okay, that one's hard. There is a trick to these ones. Okay, these ones are pretty easy. This is a combustion reaction. It seems very daunting because it's very hard, big numbers, but the trick to these is straight up. You have to make oxygen even when balancing the hydrogens. Okay, so this is the trick to these questions. That one was just crap. This one here, I'm sorry, that one's crap. Forget about that one. All right. So what I mean by this is, look here. How many hydrogens do you have? In organic compounds, first off, especially in this type of reaction in combustion, the hydrogen is almost 100% is even number, okay? The hydrogen over here is also even number. So what I make oxygen even when balancing the hydrogen. So how would I get 14 hydrogen over here? I'm going to I'd put a 7 here, right? You see it's really small. Is 7 oxygen an even number? Well, no, it's not. So what that means is you then need to double the number up here, meaning you need 2 of these, okay? That would put 28 here. Well, what would the hydrogen be to get 28? It would be 14. So that makes that an even number, okay? So in order to get that to 28, we added a 2 there. So hydrogen's now 28 here, and I got 28 here. Oxygen right here is 14. So the next thing you need to do is balance your carbons here. I have 12 here. So how do I get 12 carbons right here? 12. The reason you balance the hydrogens first and make them an even number so that the oxygen is even, this coefficient has to always be even so that this is an even number on the oxygen. Because now, regardless of whatever this number is here, anytime you times that by 2, it's going to be an even number anytime. So I have 24 oxygen there, and I have 14 here, which gives me 38 total, correct? How do I get this to 38? Times it by 19. And just like that, that thing is balanced. Combustion reactions are very easy. You balance it based off the hydrogen first, okay? Yeah, that number, that one above that, though, that thing was a doozy. You look at the numbers now, and yeah, see, when I wrote this thing, I guess I told you there's a little answer key now back there, so you guys aren't all going to cheat and go use that, right? Just so you know, you get out of this what you put into this. There is no answer. There is no answer key on the test, right? All right, so let's do one more before we move on, and then after that, we're done with balancing reactions. It's just balancing reactions, as you can see, the more you practice it, the better you get. Obviously, that one's really hard, okay? That's an exception, but Let's try. This one's only got 2 things to balance. I don't know how hard it is, but I'll give everyone like a minute to do that one. We'll give it a try and then we will move on. Okay. I promise there isn't any more. Well, there's PowerPoint later, but there ain't a PowerPoint now. Okay. Coming up. So I'll give everyone a couple minutes, try this one, and then we'll go over it together. Oh yeah, that one. I give everyone a minute. That one's super easy. All right. So last one before we move on to math. Okay. Or move on to the next part. Here we have 4 phosphorus. I have 2 here. So how do I get that to 4? And make sure that this is going to be an even number. So I'm going to put 2 here, 4, 6, oxygen, and then this is 3. That one was super easy. After I gave it to everyone, I was like, never mind, that one was pretty easy. So, okay, all right. I mean, we're at almost halftime. We take a break anyway, right, Matt? Should we just do the 10-minute
Yeah,
break
if you
before we
want to
start the
do
other
that,
part?
we're 9:22. I don't know if you're intending to go all the way to 11, but certainly we can do a
Oh,
10-minute
we'll be
break at this
close.
point.
Oh, I mean, we have to be close. We don't get to see if we don't. So, and we are the state, so we kind of have to stick to our own motto. You know what I'm saying? So, yeah, let's go ahead and take a 10-minute break now, before we start the other section, and then we'll go ahead and start the other section. All right.
All right, I'll throw up a clock.
All right, well, we should all be getting back from break. And coming in with this, we're gonna have a poll question that we have to answer. Just personal life is tough. That's all I can say is just, especially if you have little ones, given you know, our proximity to what happened last night. So, but like again, like I said, my thoughts go out to anyone who was affected with what happened yesterday and last night. So here's the first poll question. Don't forget that you do have to answer these for CECs. We will be carrying on after this poll is completed.
Just to clarify, Scott, this is the second poll question. All right, that was a quick one. We're at 100%, so I'm going to go ahead and end that poll and turn it, actually share the results here. So it looks like we've got one person that
And I think I know who that is. That
Sessions.
might be the one I got the email about earlier that I sent to you. Maybe, maybe not. You know what I'm saying? But yeah, that's good. I'm glad to see. So I guess all that other stuff was probably review for everyone. But hey, it's been a week, right? Did anyone forget it? Just out of curiosity. So, you know, our numbers seem to be a little bit. We're missing a few people compared to last week, aren't we?
Yeah, I think we're down a little bit.
Yeah, because we're at like 57, 58. So, all right. So just we're getting back. So this was the balancing reaction, right? The equations. So right after that slideshow in the packet that was sent to you, you're going to see this, okay, which is rules of fractions. So it's like, I don't know, 12 pages or something like that in something like that. So here we are at the rules of fractions. All right. So with the rules of fractions, we need to go over some of the math that's here. Okay. And the reason that we're going to go over some of it is because it's really important that we understand how fractions work and again, how unit conversions work. Okay. So this is how we'll probably be spending the rest of the day is doing this. And this is not a PowerPoint. This is me working through this with everyone on the call via camera. And this stuff is very important. I know everyone's like, rules of fractions. Pfft, what's that got to do with anything? Trust me when I'm saying I'm not blowing smoke here. Okay. This stuff is very important for what we are going to do tomorrow. 110%. Okay. Because if you can't do this, tomorrow is going to be pretty hard for you. All right. Let's just put it that way. So, so the very first rule of fractions. So when one of the problems that we have when we see fractions, especially if it's a commonality fraction, and by commonality, I mean a fraction that is like half, right? Because what everyone seems to think of was when they think of half is if we were to say, you know, this glass, we'll just say, imagine this is a glass, right? And we go like this. When I tell you the glass is half full, you imagine this as that's what it is, correct? And it's not that that's wrong, but the thing about it is that is using the half as a description of something. It's not actually what it is. So what a fraction really is not a description. Okay. The fraction half. So here's my phone. Here's a calculator. I have two things. Do you agree with that? The fraction here says 1/2. So how a fraction really works and what it really is saying is it's the reflective. The bottom of a fraction is referred to as like a system of whatever, a group of something or a whole of something. Does that make sense? A whole of something. And the fraction half is actually saying you have 1/2 of things. Does that make sense? It's saying the whole thing, whatever it is, there's two of them, and you have 1/2. That's what a fraction really is stating, not it's half empty like that. So really a fraction is saying you have part of over the whole thing, regardless of whatever the whole thing is. Does that make sense? Over the whole thing. Yeah, sorry, that was crappy. Yeah, whole thing. So in that regard, if I said you have 3/7, that means whatever it is, there's 7 of something. And you have 3 of the 7, okay? The other thing about first rule of fractions is it is also 3 divided by 7, which would give you a decimal, okay? So that's really a first rule of fractions, and 3 divided by 7, so it's top divided by bottom. It's really important to understand how that works with fractions, and it comes out to 0.43, okay? Don't believe I talk about that in here, do I? I do not, okay. Oh, wait, I saw it. Now I sort of talk about it, okay. So that gives you a decimal. This is really what the first rule of fractions is it's stating that it is actually a division and what it means. It's part of the whole thing. I don't care if you know numerator and denominator, by the way. That's why I didn't even talk about it. So not a big deal with terminology, but understanding how things work. Part of goes over whatever the whole thing ever is. And they will give you a decimal, okay? Rule 2 of fractions is stating that anytime something is divided by itself, it equals 1, okay? So 5/5 equals 1. 2/2 equals 1. Or units. If they are on the top of a fraction and the bottom of a fraction, what we want to get understanding is they cancel out and equal 1, okay? Same goes with feet and feet. They cancel out and equal 1, okay? How about inch over inch? What's inch over inch equal? I guess I better put the periods here so you know it's abbreviated. Inch over inch cancels and equals 1. They cancel out. So the second rule of fractions is saying if something is on the top of a fraction and the bottom of a fraction, they cancel out and equal 1. That's what the second rule of fractions is. This one is going to be very important. All right, the next one, rule 3. What rule 3 is saying is that anything divided by 1 is itself. 7 divided by 1, 11 divided by 1 is 11. 6 feet divided by 1 is 6 feet. 2.2 miles is divided by 1 is 2.2 miles. How about the number, we'll go with just 9. My first question is number 9 a fraction? Well, it can be over 1, can't it? Because anything divided by 1 is itself. So truly what the third rule of fractions is saying that anything can be over 1. The third rule of fractions is stating that anything can be over 1. Okay, so here on this page and the top of the next page, there are some questions I want you all to do on your own. I'll give you 2 minutes to do them because they're super easy. All right, everyone done already, I hope, because it is pretty straightforward how to do these. All right, so 3 divided by 11. Well, that is 0.3. No, it's not. Hold on. I take that back. It is 0.27 repeating. 7 divided by 7 is 1, because those cancel and equal 1. 22 inches over a question mark is 20. So this is a 1. You see what I said? These are super easy, right? It's only give you a couple minutes to do these. All right. right. This one, 7 divided by 21. This one's 0.33. I know for a fact it is. All right. 3911 divided by 3911. 1. 17 kilometers, 70 km or kilometers divided by. This is also 1. All right. Those cancel equal 1. And then 49 divided by 121 is 0.40. Mile over mile. All those cancel equal 1, and 8.4 gallons over what equals? Well, it's over 1. Okay. All right. Now that we got those out of the way, that was super easy, right? So quick question for you. We got decimals, we got percents here. I just want to go over this with everyone real quick. So fractions and decimals are related. Whenever we do a fraction like we did to this, 3 divided by 11, I got 0.43. So whenever I have a decimal like this is also linked to percentage, all right? So if we want to convert a decimal to percent, you simply move 1, 2 places to the right. All right, so decimal, 2%. It's 2 places to the right. Now, if you want to go from percent to decimal, what do you think you should do? So like, we'll go with 13% equals what as a decimal? Well, there is no decimal here, but it is right here. You go 1, 2. This becomes 0.13. So it's 2 places to the left. Any blank spot when moving should be filled with a 0. Okay. So this is proverbial quote unquote homework or something for you. And another thing you should know, okay, always convert percent to decimal, okay? Whenever you go to do math, you should always convert a percent to decimal, I promise, okay? We won't really do any of that work in here because we're going to focus on unit conversions and all that stuff. But I'm just telling you for future reference on your own, whenever you're doing this, you should always convert percent to decimal, okay? If you don't, I'm promising you, your math will be wrong. And on a test, they will be wrong answers based on not converting percents to decimals, okay? So just want to be very clear with that. You know, there's something else I want to do right here. So in this packet, you go to page 4, all right? And page 4 has number 3 on it. All right, so page 4, number 3. If you're with people, do this yourself, all right? Don't try to, do it together. Do this yourself, number 3 on this page, and I want to see what we get. All right. I'm gonna give everyone a couple minutes to do this, then we'll move on into unit conversions, okay? But this is something that just as a math teacher, as a instructor, is driving me nuts for the last 10 years. I've been an instructor for 10 years doing this. Not quite. 10 years, I guess, isn't till fall. Okay. Yeah. My very first class was Gull Lake, teaching on an overhead projector, teaching basic math and hydraulics. So I want to go over this first, and then we'll move on to the important stuff. Okay. This is important. This is important. Just I can't help but teach it. All right. So we should probably all have an answer by now. Now, let me just throw something out there and I'll explain. But if you got this, where did I just put it here? If you got this number, you're wrong. Okay, now let me explain why you're wrong. All right, so there has been a common problem with math instruction over, I don't know, forever. But some math teachers are good and some are bad. So here I'm going to give you PEMDAS. Some remember it as PEMDAS or some remember it as please excuse my dear Aunt Sally. Okay. So please excuse my dear Aunt Sally is wrong. Okay. Because it goes, please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract. Okay. A lot of people use this for their what we call order of operations in math, correct? The thing about it is that is wrong. And the reason that it is wrong is it makes you imply that, you should multiply before you divide, you should add before you subtract, and you should do parentheses and exponents, parentheses first, exponents last kind of thing. So the reason that those are wrong is math is built in what I like to call the degrees of math, right? And what that means is the order that things should be done, if that makes sense. And they're wrong because you do not multiply before you divide. And let me show you what I mean. I like to teach order of operations in the degrees that math is based on. So there's the first degree, there's the second degree, and there is the third degree of math, okay? And these are kind of like a sliding scale. It's first, second, third as you kind of move to the basement, right? As you go down the stairs or whatever you want to call it. And on the first level, you have parentheses, exponents, and another one that's left out is square root. You actually are supposed to do square root ahead of anything else. Then there's multiply and divide, and then there is add and subtract. Well, Scott, on second level here, you're telling me multiply and divide are the same, but it looks like multiply comes first. That's true. It does look like that, but that is not how you assume this is done. When things are on the same level, you do them at the same time. Does that make sense what I'm saying? When they're on the same level, you go left to right, just like reading a book. So multiply and divide, if they are on the same level, you just go, if they're in the same equation, you go left to right, regardless. You do not do one before the other. So in number 3, 8, 10 divided by 8 times by 6, are they the same level? Excuse me. Yes, they are. They are both on the second level of math. So with knowing that, you go left to right, okay? So left to right would imply that I do 8, 10 divided by 8, which comes up to 101.25. You times that by 6, you're going to get a thing of 607.5. So if you got 607.5, you did it correctly. If you did not, you didn't do it correctly, okay? So to prove my
Scott,
point.
we do have a question in the comment regarding square roots, and doesn't square root fall under the label of exponent?
Mostly just a comment. It's the reverse of an exponent.
Okay.
Its mathematical function is separate though, because it is the opposite of it. Does that make sense? But they're still based on the order of operations of being in the first degree of math, right, Forrest? Okay, so to prove my point too, I also like to do this. We all agree that this is a scientific calculator, right? And the guy that made this or invented this is probably smarter than everyone on this phone call, including myself, all right? Maybe you invented something that's crazy good too, but I'm just saying the guy invented this thing super smart, right? We all agree with that. If I type the equation into my calculator That's what it looks like. 810 divided by 8 times by 6, correct? I think we can all see that. If I hit the enter button, look at 607.5. So I rest my case with order of operations. You do not multiply before you divide. They are on the same level of math. You go left to right. Okay? I want to point this out because this is important with understanding how mathematical operations work correctly, especially when doing algebraic manipulation, which there won't be any in this class, but on your exams, there is some. All right. So I want to point this out, how order of operations works. All right. Because so many people, if you've read Facebook math stuff, know not how to. I swear, I feel like half our population doesn't know how to do math properly, like this type of question. So if I can impress upon people order of operations whenever I can, I try to show them how it works. I will tell you, whenever I run into young people, not all, but I will say most, they always do it wrong because they think it means multiply, then divide. Okay. All right. So unit conversions. Okay, so unit conversions is super important. All right. It is a must that we know how to do these. Okay. If we don't know how to do unit conversions, stoichiometry tomorrow is going to be really tough. Okay, I promise. Because stoichiometry is the fancy chemistry word we use for unit conversions. It's the same thing, just the factors are different and the conversion factors come from different spots. Okay, they're not like the conversion factors that we're going to use today, but the process is identical. Okay, so the very first thing with unit conversions is understanding what they are. Okay, so first off, in here we have 1 foot equals 12 inches. And the thing about that is known as a ratio. 1 foot equals 12 inches is known as a ratio. And in simple terms, the definition of a ratio is that two different numbers equal one another or equal each other. Is 1 and 12 the same number? They are not. Okay, 1 and 12 are not the same number. The units you attach to them change what they are, but they are not the same number. Okay, so that's my ratio. 1 foot equals 12 inches is a ratio. Another terminology for that is a conversion factor. It is a conversion factor, okay? And then ratios are also governed by what we like to call the law of proportions. And what that means basically is that you can write a ratio as a fraction, okay? So what I mean by that is 1 foot can be over 12 inches, kind of like this. Or it can be 12 inches over 1 foot. Okay. The law of proportion states that these will be equal to each other. Well, if we were to multiply those together, if it's on the top and bottom, what happens to them? They cancel. If it's on the top and bottom, what happens to them? They cancel. So all in all, this thing is going to equal 1. Well, when things equal 1, what does that mean? That means they are equal to each other. Does that make sense? Okay. So I just want to make that upon you that you can write a conversion factor as a fraction. So why is that important? Well, it's important because when doing conversion factors, we need ratios or conversion factors written as fractions. Okay. So how do we do that? Let's go to the very first example here so we can walk through how we do one of these. I have 8 miles plus 4 feet plus 50 yards, and we want to know what they all equal in feet. Okay. So I'm going to go ahead and you could do it if you want. I'm going to cross this off and I'm going to cross this off. The reason I'm crossing them off is I'm going to walk you through them and how to do it and explain what I'm doing as I go. Because just having numbers written out is a lot like doing PowerPoint math, right? Who's ever sat through a math class that's PowerPoint and goes, yeah, that wasn't much fun. Yeah, well, I have, sure. Most of you have at some point, all right? So the very first thing I'm going to start with is 8 miles. So with unit conversions, it's really like a 3-step process, maybe 4-step. It just kind of depends. So the very first thing you do is you write down what you're starting with, okay? And it is very important that you write your units, because if you do not write your units, you don't know what you're doing. Let's just put it that way, okay? You get confused. So I am writing what I'm starting with first, which is 8 miles. So my first question is 8 miles a fraction? Well, it can be, because the third rule of fractions is that anything divided by 1 is itself, or the true rule was assume that any whole number or any factor can be put over 1. Okay, so 8 miles can be over 1. It is a fraction. Now think about a conversion factor you know that has miles and feet in it. Well, I know that 1 mile equals 5,280 feet. Okay, that can be written as a fraction, right? I can write it as 1 mile over 5,280 feet, or 5,280 feet over 1 mile, like this, correct? I can write it either way. Okay, now why do I write them as fractions? Okay, so it's really important right here is why. Okay, the second rule of fractions we talked about. So the very first thing you do is write down what you're starting with. The second is to identify your conversion factor, okay? Which in this case, it's 1 mile equals 5,280 feet. So the second rule of fractions we talked about was if it's on the top and the bottom, they cancel out, right? So look at my units here. I have miles on the top, so where would miles have to be to cancel? Miles would have to be on the bottom. And if you wrote your fractions out, which of these two has miles on the bottom? Well, it looks like it's this one. So I'm going to put 1 mile on the bottom. And then what would I put up here? What's attached to it here? 5,280 feet. Miles cancels. And then you're left with this. Okay, so the next big problem that a lot of people have with these is how do you do the math on these, okay? I'm promising you right now in stoichiometry, these will be longer than 1 step, almost always, okay? But for this today, it's going to be 1 step. How do I do the math on this? Okay. Let me ask you, what does that look like? Well, that looks like it says 8 times 5,280 feet, doesn't it? Sure does. So I'm going to write 42,240 feet. I'm going to pretend I did that in my calculator, okay? Now, we ignore the top numbers and what's this look like? Well, that looks like it says 1 times 1. What's 1 times 1? Well, it's 1. So it's just over 1, doesn't matter. Okay. So how you do the math on these, I do this even in chemistry, like stoichiometry. You everything across the top, everything across the bottom. And then if you need to, you divide at the end. Do I need to divide here? I do not. It's over 1. Okay. So that's how you do the math on these. That is unit conversions. You write what you start with. You find your conversion factor. You write down the conversion factor, and then you just do the math. So it's a 4-step process, okay? All right, the next one is 50 yards. So I'm starting with. It is over 1. Well, I know that 1 yard equals 3 feet. Kind of like this, okay? So my yards are where? They are on the top. Where do they need to be to cancel? They need to be on the bottom here. So I know my conversion factor is 1 yard equals 3 feet. So you take the yards has to be on the bottom, and then ask yourself, ignore this and go, well, what does 1 yard equal? It equals 3 feet. The only thing that ever goes in those conversion factors is what is linked to them. 1 yard and 3 feet, because a common mistake is a lot of people, if they see 50 yards here, they think they should write 50 yards down here. Well, that's not true, because it's only a conversion factor. You ignore this after you've decided what goes top and bottom. If it's on the top, it has to be on the bottom to cancel, like that. Do the math. And this comes out to 150 yards. And being I have ones on the bottom, I don't need to necessarily go and put this over 1, right? Because it's just 150 divided by 1 is 150 yards. So that's how that works. All right. Now, the next thing is the next example here. I want to show, I'm not going to do yards because I just did it. Feet's already in feet, but inches to feet. Okay, so I'm going to go ahead and cross this one out because I'm going to do this one anyway. So I'm starting with 10 inches. Do we all agree with that? I need to get it to feet. Well, this is over 1. I know that 1 foot equals 12 inches. And here, I'm going to put my inches where? So my inches are on the top. Where do my inches have to be to cancel? They have to be on the bottom to cancel, which is right here. Okay. So 12 inches comes from my conversion factor. It's on top. Inches got to be on the bottom to cancel. And then 12 inches equals 1 foot. So I put that up top. And now we do the math kind of like we did earlier. You do the top. 10 times 1 is 10. 1 times 12 is 12. Now you see how there's 2 numbers here? There isn't just a 1. What do you need to do to this? You do 10 divided by 12. That will give you your answer, which is 0.83 feet. Okay? So that's how you do a conversion factor. Sometimes there will be division here. All right, sometimes there will be division, 0.83 feet. It does happen, all right? So it is there. That's how it works. Okay, next page. All right, a storage tank holds, here at the top, I have 1 cubic foot equals 0.748 gallons. I have 1 gallon equals 8.34 pounds. All right. One thing I want to talk about real quick on this one, just so we're aware, okay? 1 cubic foot equals 7.48 gallons. So you see there's no label over here. It just says gallons, okay? The reason there is no label, I'm going to try my best. I'm probably going to screw this up, but I'm not an artist. I'm a math teacher and chemist and stuff like that. So all right, so what we got going on here is I have a cubic foot. I have a box that's a cubic foot. If I put any liquid, that's the key. Any liquid in here, how many gallons is it going to be? Think about it for a second. Any liquid, motor oil, apple juice, bleach, water, mercury. How many gallons would it be? Any liquid would be 7.48 gallons for 1 cubic foot. This is a universal constant, just so we're all aware. Does not matter any liquid you put in that cubic box, it will be 7.48 gallons, okay? So just keep that in context, because we sometimes ask questions that says, how many gallons of solution or how many gallons of bleach will be in a drum that's, 10 foot high by diameter 2 foot or whatever. The conversion factor you're still going to use would be 1 times 7 point, or 1 equals 1 cubic foot equals 7.48 gallons. Sorry, struggling with that. So 1 cubic foot equals 7.48 gallons. 1 gallon of water weighs 8.34 pounds. Now, that's not universal constant, right? Because motor oil weighs more than water, or bleach weighs more than water, right? It all weighs something different, so that's not true. I ignore the 62.4. And the reason for that is you use these ones so much, you will know them. And these are hydraulic terms. 1 foot of water equals 0.43 psi, and 1 psi equals 2.31 feet of head. And just basically, it just means that if you have a tube that's, this high, 2.31 feet, that there's going to be a made here of 1 psi. Okay, that's it. We're not going to talk about that any further than that. Okay. A storage tank holds 2,000 cubic feet of water. All right. Being that it holds 2,000 cubic feet of water, A says how much will the water weigh, and B says, A says how many gallons of water, and B says how much will the water weigh. So I have 2 steps here. So I'm starting with 2,000 cubic feet. That is over 1. Okay. So for A, how many gallons of water will the tank, how will it hold? Well, I know that 1 cubic foot equals 7.48 gallons. So where are my cubic feet in rep here? Are they top or bottom in this fraction? They're on the top. If they're on the top, where do they have to be to cancel? On the bottom. Well, how many cubic feet, according to my conversion factor, should I write there? 1. 2,000 cubic feet over 1 cubic feet. Okay. The cubic feet would cancel, absolutely. But what does 1 cubic foot equal? This is what I teach people, is ask yourself, what does 1 cubic foot equal? Ignore the rest. 1 cubic foot equals 7.48 gallons. Okay. There is a math formula sheet. Matt, I think, sent it last week. It is on our website. Everyone has access to that math formula sheet. That math formula sheet contains conversion factors that you need for the certification exams. There are a couple that are not on there, and it's like time. My 7-year-old at home can tell you how many minutes are an hour, how many hours are in a day, and how many seconds are in a minute. Okay. So ones that are like that, we didn't put on there because we expect you to know that. Okay. So 2,000 cubic feet got canceled, cubic feet times 7.48. So everything this way, everything that way. Well, the top is going to be 14,960 gallons. I will not round that to 15,000 like it says here. Okay. I will make it clear. For rounding, it is 2 decimal places. I round to 2 decimal places, so you will see if a number comes out like this, 14,960 gallons, I will not round that because that comes out to a whole number. I'd even go to 2 decimal places before I round it. This book, some of this comes from some old engineering math books. And, of course they would go, oh yeah, I just rounded to 15,000. Oh yeah, well, anytime you round and then round and then round and then round, the number becomes more inaccurate. That's why I always go to 1 or 2 decimal places. All right. So just so you know, you will see me. And what I mean by 2 decimal places is kind of like this. 2.125. So here, this is 2 decimal places here. So I'm going to look at the third number behind it here and see how I round it. 5 or more, you round which way? Up. So this number I would round to 2.13. Does that make sense? 2 decimal places. I'm keeping 2 decimals. Now the next one, if I were to say 2.121, how would I round that to 2 decimals? Well, if the third number is 4 or lower, you round down, and what it means is you just drop it off, so it would stay 2.12. Just so you know, that's how I round. That's how the rounding on the exams is also done, okay? And yes, you can round as you go through math problems. So, all right. Now, how much does this amount of water weigh? Well, 14,960 gallons is over 1, because that's what I'm starting with. And I know that 1 gallon of water equals 8.34 pounds. Okay, so my next question, where's my gallons? Top or bottom? Top or bottom? Top or bottom? It is on the top. So if gallons are on the top, where do they got to go to cancel? The bottom. And remember, this is your conversion factor, which is right here. If gallons got to go on the bottom, according to this, how many gallons is it? 1. And 1 gallon equals what? 8.34 pounds, like this. Okay. So everything across the top, everything across the bottom. Bottom's only 1, so if you don't want to do it, it's fine. Just remember, it won't always be 1s. So 14,960 times 8.34. $124,766.4 pounds. So now another reason of not rounding is if someone rounds this to 15,000 and then charges you for this, is this something you're buying? You just paid for 40 gallons you don't have. Does that make sense? That's why don't round. I don't recommend it. Because some stuff can be very expensive. Has anyone in here ever bought oil for a hydropneumatic pump? And what I mean by that is like an air operated diaphragm pump, or AOD. Oil for those things is back in 2017 when I had to go buy it, it was $88 a gallon. Can you imagine 40 extra gallons of that? That's what I'm saying. That stuff gets expensive really quick. So the next page we just talked about, we just did it. This page where it says good to know, these are good to know. This one, not so much, but those, yes, are good to know. But we can skip that page. And then I want to stop here where it talks about canceling units. Okay. So the reason I'm stopping here is I want to walk through this with all of you and kind of talk about the logic of these things. Okay. So I want to go from 1 day to seconds. Okay. Yes, it's written out there, but let's go through this. Concept. A couple things to take away from this. All right. So the very first thing to think about is not the size of numbers, but let's think about the units here. So day is a large unit, isn't it? Compared to seconds. Think about that. How many seconds when this call is done will you have been on? Over 7,000 for those of you who haven't done the math yet. It'd be over 7,000 seconds by the time that this is actually done. So it's kind of like this, right? Those are seconds. Day is a much larger unit. So in reference though, think about that. So if I start with 1 day, should I have more than 1 second or less than 1 second? And what I mean by that is you're only starting with 1 day. So the number you're starting with is 1. So if I'm going from 1 day to seconds, should my number be bigger than 1 or less than 1? And if you get an answer that's less than 1, what do you think that means? It means you're wrong, right? Because logically, Oh, if I'm starting with day, there should be a ton of seconds. My number should be way bigger than 1, correct? Yeah, it should be. It should be way bigger. So logically, that's the first thing you got to look at, or try to think what you're with. And then when you find your conversion factors, just think, should my number be bigger than what I'm starting with or less than? Because typically that's how unit conversion goes. You either end up with a number that is more than the number you started with, or it is less than the number you started with. So if you can logically think about which way it should be, if you get it the opposite and you know it shouldn't be that way, then you probably did something wrong. Okay. And then the next thing with conversion factors is I don't write them down. Okay. And what I mean by that is how I've been writing 1 day equals 24 hours or something. When you get good enough at them, I don't write them down. I write them down when I'm teaching all of you because it's for your benefit, to try to help you out with understanding. I've been doing this for, hate to say it, but I've been doing unit conversions for over 20 years now. I'm only 34 and I've already got 20 years experience doing it, so that's good, right? But the next logical progression that I do think about, mine is in my head and yours can be written down or in your head too, does not matter, is to think about the conversion factors that we got to have to get where we want to go, build our bridge, so to speak. Well, if I want to go days to seconds, I'm working sort of down in size of units. So I'm going to make my thing 1 day equals 24 hours. Okay. Well, that gets me to hours. So my next step down from hours would logically be minutes, correct? Does anyone know how many seconds are in an hour? I do. I think I need a better hobby. All right. So it's 60 minutes. Now here I'm starting with 1 minute because I'm at minutes. And then of course this would be just 60 seconds. So you see the bridge, so to speak, or the path to seconds that we're trying to get to. All right. So I'm going to start with 1 day over 1. Well, if days are on top, where do days need to be to cancel? On the bottom. So the conversion factor that I know that has days in it also has 24 hours. So my days cancel. Now I'm at hours. If my hours are up top, they got to be where to cancel on the bottom. 1 hour equals 60 minutes. And then I'm at minutes. If minutes are on top, where do they have to be to cancel? On the bottom. And then 60 seconds goes up top. And as you can see, as we worked through this using our conversion factors, you can see it's 1, 2, 3 steps long. A lot of them you're going to see in stoichiometry tomorrow will be 2, 3, 4, 5, maybe even 6 long. Some of them can be that long. But 2 to 4, 2 to 5 is pretty typical for stoichiometry. So logically going through this, and then you just have the top, bottom. So there are 86,400 seconds in a day. That's a fairly large number, isn't it? All right, so I just wanted to show and describe the logic that you can think about with these things too, and help understand what's going on. Okay. And I think it's done with this. Yeah, it is. Okay. Now, a basin has a volume of 1,500 cubic feet. How many gallons could this hold? All right. So I'm starting with 1,500 cubic feet. That is over 1. Well, I got to get it to gallons, so I know that 1 cubic foot equals 7.48 gallons, kind of like this. So if my cubic feet are up top, where do they have to be to cancel? So if cubic feet on top, where should we put them to cancel? Well, down here, 1 cubic foot. And then 1 cubic foot equals, that's what goes with it, 7.48 gallons. So I'm going to do this, and this is going to give me 11,220 gallons. And just multiply across here. Cubic feet canceled, and you're good to go. All right. We have 16,456 gallons of water need to be transferred to a basin. What is the minimum number of cubic feet the basin must be in order to be adequate to hold this amount of water? So what am I starting with there? I'm starting with 16,456 gallons. Is that a fraction? Well, yeah, it's over 1. I'm going to use the same conversion factor because I need to convert to cubic feet. So 1 cubic foot equals 7.48 gallons. My gallons are on top, so where do my gallons have to be to cancel? Right here in the bottom, 7.48 gallons. Okay. If gallons cancel, what is 7.48 gallons equal to? 1 cubic foot. So when I do the math this time, I got 16,456. Now that got to be over 7.48 gallons. Because 1 times 7.48 is 7.48. All right, and do the math here. 16,456 divided by 7.48 comes out to 2,200 cubic feet. All right, so quick. Now that we've done that, you're gonna see on the back side of this, there is this. Yeah, but before we do that, go one more page and let me do number 7. Number 7's a little bit more complicated, and I hate to say it, but number 7 is more representative of how unit conversions work in stoichiometry. Okay, there are often double units, meaning like grams per this or something like that. So how does this work? I have 9 CFS. CFS stands for 9 cubic feet. I recommend, until you master this, writing down as you go. So 9 cubic feet, and then 9 cubic feet. So I wrote it out, 9 cubic feet. And then I'm going to say the word per 1 second. Does everyone get what the per is? Per equals the fraction bar. Per equals fraction bar splitting the units. You know, the biggest mistake I see with these half the time is this. People write it as 9 cubic feet per second, like this, over 1. And that is not how it's written. This is wrong. It's 9 cubic feet per 1 second. So it's pretty much you write the first unit, you put it over 1, and then the second unit is what goes with the 1 that we've been putting on below every other time. Does that make sense? All right, well, I need to get this to gallons per minute. So that unit is going to look something like this. Do those match? Not at all. So now you got to think about conversion factors. I got to get cubic feet to gallons. Well, I know that one. 1 cubic foot equals 7.48 gallons. And I need to get seconds to minutes. Well, I know that 1 minute equals 60 seconds. All right. So my first question is, does it matter if you convert the top or bottom unit first of these two? Does it matter which one you convert first? First off, it does not. So I'm going to start with seconds. The seconds are on the bottom here. Where do they got to be to cancel? Well, they got to be up here. Well, how many seconds? Because I'm going to minutes. So 60 seconds over 1 minute, like this. Seconds cancel. I got minutes, and look, minutes and minutes. That works. Now, if I have cubic feet on top here, where do cubic feet have to go to cancel? On the bottom. So even though they're separated by this, if it's on the top and bottom like it is here, even if separated by the other conversion factors, they still cancel out. So 9 cubic feet, that was 1 cubic foot. 1 cubic foot equals 7.48 gallons up top. You just do the math. And then if you look, gallons, minutes, minutes. This is 4,039.2 gallons per minute. Okay. I just wanted to show how the double units go. All right, so go back one page. I'm going to give everyone 10 minutes to do these, do this page and the one we just looked at. Give everyone 10 minutes and then we'll go over those, okay? let's go ahead and go over these and then we will be done for today. All right, so what is the sum of 19 feet plus 30 inches plus 6 yards? All right. So, and we want it in feet. So 19 feet's already in feet. I don't have to convert that, but I do have to convert 30 inches. This is over 1. All right. I know that 12 inches equals 1 foot. So if my inches are up top, where do they have to be to cancel? On the top, they have to be on the bottom to cancel. 12 inches equals 1 foot. So when I do the multiply, I'm going to get 30 over 12, which will be 2.5 feet. Okay. Now, the next one is 6 yards. I'm starting with 6 yards here. 1 yard equals 3 feet. So my 6 yards is over 1. If my yards are up top, where do they need to be to cancel? On the bottom, 1 yard. So if yards are here, they're on top and bottom, they cancel. I put 3 feet up here because that's what's attached to the 1 yard. This will be 18 feet. Don't forget to add your 19 feet back into this. 18 plus 19 plus that is 39.5 feet. Okay. How many gallons is in 7 cubic feet of water? So I'm starting with 7 cubic feet. That is over 1. I got to get cubic feet to gallons. Well, I know that 1 cubic foot equals 7.48 gallons. Okay. So where are my cubic feet? That's way bigger than they need to be. Where are my cubic feet, on the top or bottom here, this first? They are on the top. So where do they need to be to cancel? On the bottom. Okay. So 7.48 gallons is what goes on top because that's what's attached to the cubic feet. So this will give me, I think, remember, I guess I'll do it just because I don't want to be wrong. Oops, 7 times 7.48 is 52.36 gallons. All right. How many pounds is 9 cubic feet of water? Okay, so I know I'm starting with 9 cubic feet over 1. Well, I know that there is 1 cubic foot of water equals 7.48 gallons, like above. And I know that 1 gallon equals 8.34 pounds. Because I can go cubic feet to gallons, gallons to pounds, correct? So if my cubic feet are on top, where do they need to be to cancel? Down below. And 1 cubic foot equals 7.48 gallons. So that's what goes up top. Okay. So cubic feet cancel like this. 7.48 gallons is what I'm left with, the unit of gallons. So if gallons are on top, where do they got to be to cancel? Well, down here, how many gallons? Well, my conversion factor says 1. 1 gallon equals 8.34 pounds is what goes up top. Gallons cancels like that. So I got to multiply 9. I got everything across top. The bottom is 1 times 1 times 1. So that doesn't matter. And I get 561.45 pounds. I rounded that just so everyone can see. Oh, when did that come back up? Oh, can no one see my screen? Oh, crap. Matt, can you see my screen? I can't. Okay, well, never mind. I thought something just majorly went wrong. Thanks, Forrest, for letting me know. I just wanted to show, you can see here, 561.4488. That's why it's 561.45 pounds, okay? just thought something major went wrong. Funnier things have happened. Back in October, I was like mid-class and I got kicked out of the room I was in because it was exposed to COVID here we're in our building, and they made me go to like a different room. That was fun. Anyway, 19 gallons of water will occupy how many cubic feet? I'm starting with 19 gallons, so I write it first, put it over 1. Well, I know that 1 cubic foot equals 7.48 gallons. All right, so if gallons are up top here, where do they need to be to cancel? They would go here. Well, according to my conversion factor, how many is it going to be? It's going to be 7.48 gallons. Well, 7.48 gallons equals 1 cubic foot. Cancel, cancel. This way and this way. So I'm going to have 19 times 1, and then 1 times 7.48. And I do believe it's 2.56, but I'm going to do it just to make sure. 2.54. See, this is why I do this. I don't want to get yelled at by the. Oh, I got yelled at already. Oh. Oh boy. All right, 2.54 cubic feet. Okay. I will tell you, Forrest, when I first learned chem and unit conversions before we did stoichiometry, spent like 2 weeks doing unit, and I mean, it was 2 weeks, 80 minutes every day for 2 weeks straight. So it was to beat it into our heads. So 350. So these are double unit ones now. So we have 350 feet per minute. Okay. And I want it to equal feet per second. So if you look, feet and feet are both here, but minute and seconds aren't different. So I have to convert minutes to seconds here, correct? So if my minutes are on bottom and I got to get them to seconds, where would my minutes have to be to cancel? Minutes are on bottom, so they have to be up top to cancel. So how many now? 1 minute equals what? 60 seconds. Okay, so my minutes will cancel. And I'll get 350 over 60. Because 350 times 1, 1 times 60. All right, and that will give me 5.83 feet per second. All right. Did anyone get 21,000 out of curiosity? Because that happens a lot on this. It can't be 21,000 because if it was, does that even make any sense? This is saying 350 feet per minute, right? So if it was 21,000, that wouldn't make any sense. So because you're telling me in 1 second you go 21,000, where in a minute you only go 350, it doesn't make any sense, right? Okay, convert 750 gallons per minute to gallons per day. So 750 gallons over 1 like before, but remember that 1 has a minutes on it now, okay? So I need to get this to gallons per day. Some people know how many minutes are in a day. That is, it's not common knowledge, but it would surprise you. If we were in a class all together and people raise their hands, I would say about 35% of the class know that. So, but anyway, 60 minutes equals 1 hour. And then there's 24, oh boy, 24 hours equal 1 day. Okay, so if minutes are on the bottom, where do my minutes have to go to cancel? They have to go on the top. So 60 minutes here, and 60 minutes equals 1 hour. Okay, so that cancels that. And if I have hours in the bottom, where do hours have to go to cancel? 24 hours here. 24 hours equal 1 day. So they would cancel like that. This would be 1,080,000 gallons per day. Okay. Oh, that being said, now the next thing here. Um, 4,039.2 gallons per minute. Oh, that's what that equaled. All right. Okay. 560 highlight gallons per 1 minute. I need to get it to CFS, which is cubic feet per second. Okay. So I'm going to need the same conversion factors I used right here. I'm going to start with gallons. I usually start with a top unit just to get rid of it. So if gallons are on top, where do my gallons have to be to cancel? They got to be on the bottom here. Okay. So that puts my cubic feet up here. Gallons cancel, gallons cancel. Now, if minutes are on bottom, where do minutes have to go to cancel? On the top. 1 minute equals 60 seconds. So that cancels minutes. And now we do the math. 560 times 1 is 560. 1 times 7.48 times 60 is 448.8. Now I can divide them, and I'm going to get 1.25 cubic feet per second. Okay. So there's 2 or 3 more sheets of unit. There's 4 of them. Unit conversions for everyone to do. Okay. As homework, learn how to do it, because tomorrow we're going to be, maybe everyone doesn't have it written down. Hold on, put that back. Tomorrow we are going to be running into stoichiometry. Okay. We will first discuss where your conversion factors are going to come from. We're going to discuss the idea of a mole, and then we are going to go right at it. We are going to be doing stoichiometry for at least an hour, if not more, tomorrow. Okay. And stoichiometry is unit conversions of chemistry, and it is absolute necessary that you understand how to do it. It is the basis for all chemistry, to be honest with you. And that is the part of anyone who's taking an F1 or 2 exam, softening questions and sludge calculations involve safe